Okay, I want you to construct the graph of this function. I want to see how you're doing, okay? To construct a graph doesn't mean you start plugging in values for x into this function. It means you start with the basic function. And I had a square there. I don't want that square. Bracket's too big, okay? Actually, it's not that bad, but we're not gonna do the square. Because I got the 3 there. So we start with what graph? What function is this a transformation of?
1 over x.
It's 1 over x, right? You should recognize that immediately. Okay, this is 1 over x. Construct the graph. Okay, this is 1 over x. What's the first transformation that you have to do in order to get this?
Multiply by 3.
Okay, what transformation is that?
Multiply the y by 3.
What do we call that?
Vertical stretching.
Yes, that's what I wanted you to say. Everybody knew that. We're just waiting for him to mess up twice, right? Okay? He didn't mess up. All his answers were okay, but vertical stretch is what we're looking at, right? And we want to be able to write out these words because they have meaning that's going to cause you not to screw up once you get in the habit of writing them all out and then thinking about what they mean. Okay, it's vertically stretched by factor 3 because if you multiply this by 3, you get 3 over x, right? Okay? And you need 3 over a transformed version of x. Then what do we have to do? There are 2 more things we have to do. It doesn't really matter what order we do them in. So there are 2 possible answers to the question of what's the next thing we do.
Your horizontal or vertical shift.
I'm sorry, Daniel.
Your horizontal shift or your vertical shift.
Okay, we're going to do a horizontal shift and a vertical shift, right? Which one do we want to do first? Pick. Okay, let's all vote. How many want to do the horizontal shift first and how many want to do the vertical? It's horizontal shift. Hold up your hands. Vertical shift. Okay, so you didn't vote. Anybody doesn't want to do anything? Now you voted twice. Okay. Vertically stretched by factor 3. Okay, so we do the horizontal shift. What's the horizontal shift? How far do we shift it and in what direction?
5 points to the right.
5 to the right because x in this expression has been replaced by x minus 5, right? Now if you don't know this, you look in your book, look up graphing by transformations on the internet. You'll have 17 million responses and then you got to make a decision, right? Okay? Actually look at the first one. If you don't like it, look at the second one. You know, probably going to see good stuff. Okay? Or look back at the videos from January when we did this. Or look at your book. Okay, horizontal shift of plus 5 units. And then what? There's only one left. And it's a vertical shift, and you know it, you're just not seeing. Vertical shift of negative 2 units, right? Okay? Well, let's start with the graph of 1 over x. And since we're going to be multiplying it by 3, that's going to triple the y coordinates, right? So we don't want to use a huge scale on the y. So I'm going to do this. I'm going to say, well, I know that when x is 1/2, 1 over x is 2. And when I do the vertical stretch by factor 3, it's going to become 6, right? So I'm going to put 6 up here, which would put 4 here and 2 here. Now I'm trying to think ahead so I don't have to go through a bunch of trial and error, draw a graph and then it doesn't fit because I got all this writing here. So I'm trying to anticipate a little bit, which is unusual for me, okay? But it's not a bad idea. I don't want to have to redo it, I don't have to erase and redraw my graph, so I'm trying to use a little foresight. Again, you're not used to that, so don't be shocked, but try to do it yourself. Okay, so my points, well, this is going to be 1, and I don't have to make the table this time because I really shouldn't have to make the table to graph any basic function. You shouldn't have to make a table to graph any basic function by this point in the course because you've already made it dozens of times and you already know what the numbers are going to be. Now if you haven't done that, then you better be making tables a bunch of times until you can't possibly be wrong, and plotting the graphs so you know where those points are going to be and you can always figure them out in your head, hopefully. Not everybody's good at figuring things out in their head, so if you got to write them out, that's okay. But one way or another, you should be really familiar with these graphs. So -2 would be here. So here are the 3 points that we've got over here. And the -1 is kind of in the way, so I'll kind of put it up here. And then I can sketch the graph at least here. And now I know that this graph just goes crazy in the vertical direction. Becomes asymptotic to the y-axis. Going crazy is a really profound mathematical term, but it's not all that specific. It approaches the y-axis as an asymptote, okay? And of course we know it approaches the x-axis as an asymptote. So we draw something reasonable. And reasonable is all I want, okay? Just don't put any loops in it, stuff like that. You know better. Okay. Now I've got to vertically stretch it. Now I'm going to do this fast, because you should already know this. If you don't, look it up. Okay. Vertically stretched by factor 3 means every point moves 3 times as far from the x-axis. So this point's going to move all the way up here. This point's going to move up to here. And this point is going to move up to about here. Now I used arrows, it's going to, this arrow and then 3 of them and all that stuff. So hopefully you understand that. And then how vertically stretching it by factor 3 is going to do something like this. Not very well drawn, I kind of missed that point. But every point on this graph is 3 times as far from the x-axis. Because, why? Because we're multiplying 1 over x by 3. Now, I'm going to add some to this. If we vertically stretch by factor 3, we get 3 over x. Horizontally shifting 5 units. Gives us 3x minus 3 over x minus 5. Three didn't come out. And then when we do the vertical shift of -2 units, that's going to give us 3 over x minus 5 minus 2. You want to understand all of that completely. Okay, so let's see, we're going to horizontally shift 5 units. So that means we take every point here. Now, one thing we want to do, since we have a asymptote at the vertical asymptote at the y-axis, I'm going to sketch myself a y-axis shifted over 5 units. So here's 3, 4, 5. And I'm going to just sketch a dotted line here. Okay? And say the asymptote shifted 5 units in the horizontal direction. It's going to help me locate the graph and locate the asymptote a little better. So this point is going to move 5 units over, which is going to put it 2 units to the right of x equals 5. That'll be at x equals 7. This point's going to move 5 units over. This point's going to move 5 units over. So I'm going to have these 3 points. Here's going to be my graph. Then I'm going to do the same thing with the points I've got here. What am I doing? This point moves over to here. This point moves over to here, and this point moves over to about here. So now I've got my 3 points. Now I can sketch this part of the graph. So, in orange, I've got my graph of y equals 3 over x. In white, of course, I've got my graph of y equals 1 over x. And in yellow, I've got my graph of y equals 3 over x minus 5. I'm going to regret labeling it there, but forethought has its limits. Okay. Make sense? Should be very clear. We've been doing this for 2 months. 2 months and a couple of weeks. Okay, so now what do? I vertically shift -2 units, meaning every point moves 2 units down. So this point is going to move 2 units down, and this point is going to move 2 units down, and this point is going to move 2 units down, giving me 3 points like so. So now I've got a graph that does this. And all of these points move 2 units down. And I'm being a little careless. I'm not locating these points very accurately. But there we got it. Also, the horizontal axis it's a horizontal asymptote. The graph is asymptotic to the x-axis just like it is to the y-axis, right? The original graph. And since I've just vertically stretched it, well, that moves any point on the x-axis to itself because it has no distance from the x-axis. And horizontally shifting just shifts the x-axis over, still the x-axis, right? Okay? But now I shift 2 units down, so I should go ahead and shift my horizontal asymptote, my x-axis, 2 units down. I'm just trying to figure out a good place to do that. I guess I'll do that here. So now I'm going to draw a dotted line . The horizontal axis shifted -2 units vertically. And this is an asymptote, okay? So there we've got that, so we know that this thing approaches that horizontal asymptote as that horizontal dotted line as an asymptote, and there's our final function. Okay? So what we can do then is I'll just kind of put this in red to kind of emphasize it, because it's kind of a really nicely visible color. So it's kind of red-green. Anybody ever watch red-green?
Duct tape.
Pretty good show. On PBS, was it?
I can't remember. It's been
Yeah,
forever.
look them up on the internet. You'd probably like them. Extreme Canada redneck.
That's a bit of
Very
an
funny with
understatement.
tongue-in-cheek. Okay? Okay, anyhow. So I wasn't thinking of red-green when I did that, but when I put those two words together, I suddenly had a memory. Haven't watched television in 6 years, so. Okay, does that make sense? Is this how we construct a graph? So when I say construct a graph, I don't mean make a table with 1,700 points on it and plot them all. That's not a construction, that's brute force. That's what you learn to do in 5th grade. Okay, or maybe 7th grade or 6th grade. And then, yeah, this is college, right? College level pre-calculus, trying to get you ready for more college math. Okay? Trying to give you the mathematics that'll apply to your field. If mathematics applies to your field, which apparently it does if you're in here. Okay? Okay, so there we are. Now what can we do with this? Well, this video is getting long, 17 minutes. We'll stop it for a minute.